All right, we are back with part two of Mancala, and let's take a quick look at what we accomplished in part one. We're trying to simulate the Mancala board game, where you take little seeds, little marble-looking glass thingies, and you distribute them into pits. I recommend, if you have no clue what I'm talking about, you obviously didn't do your research, you should go play Mancala. Just Google Mancala, go to one of those websites, free to play, that sort of thing. So we have an integer array that represents our board, and that is kind of the big concept behind this whole project, is that we have an integer array as an instance variable, right? Even though the Mancala board is, why don't I pull up some type of visual, right? I'm going to Google the Mancala. Ooh, turn down that sound. I don't hear the music, but we got this kind of concept thing going on here. But realities are this is just something we can represent with an integer array. Right? This is going to be my index 0. It's kind of what I decided on, and we kind of go through like this nature, and we just got to kind of keep track of what bits represent what. Right? We got these little smaller bits that belong to player one, as well as player one's Mancala. We got all these smaller bits, as well as this Mancala that belongs to player two. And so we just got to keep track of that. But ultimately, it's just an integer array. We take that integer array and we initialize it in the constructor with a length of 14. So there's 14 total spaces on here. Right? Two of those are going to be Mancalas. All the other ones are going to be smaller pits. But the first thing I do, whenever we initialize this thing, it's filled with zeros. I'm going to loop through and set everything to 4 except player two's Mancala. That's an easy little adjustment to make. You could go ahead and set that to a 4. It's just not a big deal. Right? I'm actually going to do that now. And then we basically need to use these instance variables to kind of keep track of player one and player two's Mancala. Now, these aren't necessary, but they're going to clean up our program quite a bit later on. Right? So these are optional instance variables. We don't have to have them, but we go ahead and initialize them here, right? Player one's Mancala is essentially index 6. 0, 1, 2, 3, 4, 5, 6, right? So half the board length is 14, half of that 7, minus 1 is how we get our 6, and then player 2's is 1 less than the board length, 13 at the other end. Now, because I went through and put 4 into everything, that would mean that I have 4s in my Mancala spots, and I don't want that, so we are effectively rolling that back here. Okay? Several different ways you can go about this. I like the rollback approach because I think it's clean, it's simple. The preventative approach, it's whatever. All right, so this is initializing our Mancala board. Now, we of course want to be able to see that, which is why we went ahead and wrote our toString. So we kind of want to mimic this setup as much as possible. So what we decided on is that we're going to have player 2's side of the board represented in this order on one line, and then player 1 side of the board represented in this order on a new line. So let me show you the end result, and I'll talk about how we were able to accomplish that. All right, this is player 2's side of the board effectively, and this is player 1's side of the board. Right, that's how we're able to visually represent that using just strings. But we started out with an empty string. We're going to loop through player 2's side of the board. Notice that I is starting at player 2 Mancala, and right away we see this instance variable coming into play. If you didn't include this instance variable, you would need to do this, which is fine, but as you can see, that's a little bit messier, whereas this is like super clear. I've effectively labeled that spot, right? Index 13, I've labeled it. That's player 2's Mancala all day long. So we're going to start it, player 2's Mancala, and we're going to go this way. Well, that's 13, and then you go to 12, 11, 10, right? So we're actually decrementing I, and we're headed towards player 1's Mancala. I'm going to keep doing this as long as I is greater than player 1's Mancala, which is going to include all of these positions, everything that's player 2's side of the board. With each iteration, I'm going to see how many seeds are there, add that to my return string along with a space. We then make a new line using a new line character in the middle of our string. And then we loop through player 1 side of the board, starting at index 0, going up through player one's Mancala, right? Less than or equal to means that player one's Mancala will be part of this loop. And in that case, I'm incrementing I. I'm going to do the exact same thing where I pull the number of seeds, add it to my return string, and that's ultimately how we ended up with this guy. So that's what we're going to pick up today. And if I look at my public interface here, we effectively did a constructor, we effectively did a toString. I got all this I need to do. Now, the vast majority of this program is this move method. Okay, there's a lot that goes on into that one method. We're going to do basically everything else but move today. All right, starting with get seeds. Okay, get seeds returns the total number of seeds that can be found in the specified player's smaller pits, excluding their Mancala. Okay, this one's super important for determining who the winner is, because ultimately the winner is whoever has the highest number of seeds. It's excluding their Mancala. Why don't we go ahead and plug in this. So the game is over once nobody has, once one player doesn't have seeds in their smaller pits. However, ultimately the winner is, I don't know where I'm going with this. Let's just write the method. All right, I'm going to Java doc this. Returns the number of seeds on the specified player's side of the board. That's too much on one line. Let's do a new line. I'm going to indent just a little. Player's side of the board, excluding their Mancala. Okay. Small precondition here. I only have two players, yet I'm using an integer, right? So our precondition is that player is either going to be a 1 or a 2. Player is equal to 1 or player is equal to 2. Right? In theory, we could pass in any integer. 1008. There's only two really viable options. Since there's only two options, you could use a Boolean here, and that's a little bit more efficient, but it's also a little bit more confusing. When I'm like, get seeds, true, or get seeds, false, that's not going to make very much sense. When I say get seeds, 1, I think it becomes a little bit more clear that we're getting player 1 or player 2 seeds. So this is ultimately just a sum, right? I'm going to create a variable that's going to store my sum. But we're not looping through the entire integer array. We're only looping through a section depending on the player. If our player is 1, I need to loop through player 1's side of the board. Okay? We're excluding the Mancala. One thing you could do is, again, the preventative versus rollback approach. You could loop through everything, including their Mancala, and then subtract out their Mancala if you would like. That would be a rollback approach. Here, preventative is probably actually going to be easier because we're just going to write a loop that starts at index 0, and we're going to keep going as long as we are less than player 1's Mancala. Again, this label is effectively coming into play, right? I'm going to loop through everything beginning at index 0, that's here, up to player 1's Mancala. Because this is less than player 1's Mancala, we won't actually iterate on that position, that index. If our player is 1, I'm going to loop through player 1's side of the board, and with each iteration, what I want to do is get the number of seeds, add it to our sum. So sum is going to become what it was plus the current seeds. This is going to be boarded I. Hopefully you recognize that we can replace this with a shorthand assignment operator to simply just be plus equals. Okay. Otherwise, and the indentation really helps here because we are not using braces, right? Even though this looks like this if statement has multiple statements in it, there's only one statement inside this if statement, a for loop. There's only one statement inside that for loop. This assignment operator, whatever this math here, okay? If we hit this else, that means our player must be player 2 because we've preconditioned it. So I want to loop through player 2's side of the board. Okay, you could easily just kind of decrement from here if you would like, or you could basically start at this position and increment up. Either is pretty simple. So I think I'm going to start here at this position. Right? What is that index? It's effectively index 7, right? But because we have this really nice label, we could just think about it in terms of player 1's Mancala. Right? If player 1's Mancala is here, well, this was just one more than that. So I'm going to initialize I to player 1 Mancala plus 1. That's going to put us at index 7. Okay, I'm going to keep looping until we get to here, meaning I don't want to go into this spot. That's player 2's Mancala. I'm just going to prevent that from being added to my summation here. Okay, so as long as I is less than player 2's Mancala, oof, that's clean, I++. Same thing here. We're going to add that to our sum. So depending on who the player is, just changes what side that we're looping through, but we're adding to our sum no matter what. Now, you could basically create one loop, right, instead of, because effectively this is the same, right? We're looping through something and adding it up. That is effectively the same here as it is here. The only thing that's changing is our positions. So you could set up if statement situations where you're effectively just making these things variables that kind of changes. Let's look at that approach and you'll see what I mean. Okay, let's test this first and see that it works. Right, I'm going to try it out here, and it's going to be a little kind of, they're going to be the same sum no matter what player I got because they have the same number of seeds. But that's okay. We'll change up our test case a little bit. So I've created my game. We can see it clearly there. I want to know how many seeds one of the players has. So I'm going to do systemout.println. I'll take my Mancala game, and I'm going to get the seeds for player 1. Player 1 has 24 seeds, and that's correct. 6 smaller pits times 4 is 24. If I did it for player 2, I'm going to get the exact same number, and that's kind of what I mean that it's hard to tell if this is working or not, right? How do I know I'm not just getting player 1 stuff again? So here's something I recommend. For testing purposes, I would create another constructor. One that takes in an integer array. And I know I missed the brackets. One that takes in an integer array. The idea is, I'm not even going to JavaDoc this guy. I know I didn't JavaDoc this one, but I'm not even going to JavaDoc this. The idea is that this is going to help me test. I can basically send in starting board positions and use that to kind of play with my methods to see if things work. I don't necessarily need this for the game to work. I just want it for testing reasons. And so the idea is we would send in an integer array that represents our board. All we need to do in order for the rest of our program to work is save that into our instance variable. Here I'm going to have to use this dot notation because I already have something called board. Right? In this context, in this scope, I've got 2 boards. I've got the local parameter coming in, the local variable. I also have the instance variable. So I'm going to use this dot in order to differentiate between those 2. We don't have to do anything else because this board that's coming in effectively already has the seeds in whatever positions. This is going to be really good if you were actually programming this yourself and trying to test to see if your program works. Okay, so here's what I'm going to do. I'm going to comment this out. Instead of making our Mancala game through the default kind of way, I'm going to come in and make the Mancala game. But I'm going to provide it this time a board state, right? I want to basically pass in an integer array. It's occurring to me that I could have copied and pasted this and saved myself some time. Let's create an integer array that represents a board state. You can call that board. You don't have to. You can call it whatever you want. But I'm going to use an initializer list in order to give these values. Now, in order for everything to work, you're going to have 14 different integers here, right? It doesn't really matter what those are. Those are effectively player one's smaller pits, followed by player one's Mancala. Again, it doesn't matter. What I really want to do is just test my get seeds. And I need to differentiate between player one's and player two's seeds. And then lastly, player two's Mancala. All right, this should be 14 slots, right? I got 6, then player one's Mancala, 6, and then player two's Mancala, which means if I come in here and ask for player one's seeds, oh, I should probably pass it in. I created this integer array, but I didn't actually feed it to my constructor. I need to pass it in here as an argument. So we're using the overloaded constructor, the one where I get to specify. Oh, that's interesting. Was not expecting that. I set this. I did not set these things, right? Player one's Mancala is going to set a default value of 0, which is throwing off my other stuff. Ooh, testing's good. All I have to do is this. That's it. Right? I just need to set player one's Mancala. I need to set player two's Mancala, because those weren't happening in this particular constructor. They were assuming a default value of 0. Let's try that again. I'm going to hit my play button. And here we go. All right, this is player 2's side of the board. This is player 1's. 3 and 5 is 8, and 6 is 14, and another 6 is indeed 20. Okay, that looks pretty good. I am going to flip it real fast, and we know from prior experience that we should be getting 24 here. And I sure do. So that is why I would include a constructor like this, is solely to set up scenarios for you to test, right? To test to make sure that your program is working. Okay, get seeds looks good. We're doing exactly what this thing is asking us to do. Let's see what our next thing is going to be. Get board. This is probably going to be pretty simple. It looks like it may just be a simple getter. It just returns the board. Okay. I'm in Mancala. Okay, I'm going to write a getter public integer array get board. What's interesting about this one, notice our return type. We don't do this a lot, but this is going to return an integer array. I can go and tell you the whole point of this get board method is so that the GUI can work later on, right? I need to, basically in some type of driver, I need to know what the board is specifically in order to display it correctly inside of a GUI, right? I don't have direct access to it. This is giving me access. All we're doing, we need to return an integer array. There's only one. It's board, right? So get board just simply returns board. Now, the big brain thing here is alt inserting. If I do alt insert, we could generate a getter, and it's going to ask me what instance variables do I want to include here. Well, I just want this board, so I'm going to hit OK, and there it is. Okay, done and done. What do we got next? Game over. Game over's method returns true if the game is over, false otherwise. A game of Mancala is over if a player cannot move. All the smaller pits on his or her side are empty. Okay, doesn't matter where this is going, but I'm going to do public boolean game over. Let's Java doc this one because it's got some meat to it. Not a lot, but it's got some meat. Gosh, the Java doc's going to be longer than the actual body of the method. Returns true if the game is over, false otherwise. The game is over if either player cannot make a move. That is, there are no seeds in their smaller pits. Okay? I want you to think for a moment. Because we could come up with this loop where we basically loop through player one's smaller pits, see if they have seeds. We can then loop through player two's pits and see if they have seeds. But we kind of just did that, right? Notice I did not highlight the Mancalas. We're not touching the Mancalas. We're just looking at smaller pits. Well, get seeds exists. That makes this super easy. All I got to do is call the get seeds method, right? Get seeds for player one. If I do get seeds for player one, it's going to tell me how many seeds are on their side of the board. If that number happens to be 0, player one can't move. I also want to check player two because it could be either player is out of seeds. If I do get seeds for player two, it's going to loop through player two's side of the board. And if that number happens to be 0, that means they have no seeds in their smaller pits and the game is over for them. Okay, so simply put, this is a one-liner. Return get seeds for player one. If that is a 0, then the game is over, right? I'm actually going to get a true or false value thanks to this relational operator. But I need to do this for both players because it could be player one is out of seeds or player two is out of seeds, and that's what is dictating the game is over. Or get seeds for player two. If that number is 0, that means player two doesn't have any seeds in their smaller pit. And this is it, right? This is going to give me a true or false value. This is going to give me a true or false value. Overall, the true or false that we're returning is produced by this OR. Either player one is out of seeds or player two is out of seeds, or neither, right? False or false. The game is not over. Let's see what we got last here. We're looking at get winner. Returns an integer. Get winner's method should return -1, the game is not over. Otherwise, get winner should return 1 if player 1 is the winner, 2 if player 2 is the winner, or 0 if there is a tie. It is possible because the winner of the game is whoever has the most seeds on their side of the board, including their Mancala. Okay. Now, this kind of makes me wonder about this get seeds method, right? This does everything for the smaller pits. Why didn't we go ahead and include the Mancalas there? Well, ultimately, I can reuse this, kind of a sub portion of it here, right? It made my game over super easy. For the get winner method, I'm also going to use get seeds to get their smaller pits. And thanks to our labels, right, player 1 and player 2 Mancala, it's very easy to just ask, well, how many are in the Mancala? And that's how you basically get your total from there. Okay. Now, ultimately, the game is over if one person runs out of seeds. However, the winner is whoever has the most seeds, and that includes the smaller seeds that are still left on their side, and their Mancala, right? So that's how their score actually occurs. It is possible to get a tie, and that's what the 0 represents. I'm going to hop down to underneath my game over method, and let's do public int get winner. You can bet that this is going to get Java docked. I like this one at the point of return. We're going to return -1. The game is not over. 0. The game ends in a tie. Ends in a tie. 1, player 1 is the winner. Or 2, player 2 is the winner. Okay. So what I recommend when you're doing these type of things, hopefully you quickly recognize this is like if statements. And the way you want to organize this is what is the most likely thing to happen? And you put that at the top. And as it turns out, the most likely thing to happen whenever this method gets called is that maybe the game is just not over. That's an easy check. Okay, how do I know that the game is not over? Well, we wrote this. If the game is not over. Right? Notice the use of our not logical operator. We're going to call the game over method. It's going to call get seeds. Get seeds will give us back our numbers. And if the game is not over, then we just return a -1. Once we hit this return, we'll exit the method, which means if I'm still inside of the get winner method, the game is not over. I'm sorry, the game is over, right? If I hit this point, game is over. Otherwise, I would have left already. Okay, so I know the game is over at this point. I just need to see who the winner is. Again, I would look for the most likely scenario, and a tie, I can go and tell you, is the most unlikely scenario, right? So we want to look for these other things. Maybe player 1 is the winner, player 2 is the winner. Here's what I'm going to do. I'm going to go ahead and save these values into some variables, right? I want integer 1 to be the total number of seeds for player 1. That includes the smaller pits, that includes the Mancala. Well, we can use our get seeds method for player 1. That'll tell me how many smaller seeds they have. I want to add to that player 1's Mancala. That's coming from our board at player 1 Mancala. And this is the total number of seeds. I'm going to do effectively the exact same thing for player 2. We're going to get seeds for 2. We're going to pull their Mancala seeds by going to board, player 2 Mancala. And this is the total number of seeds for player 2. Okay. This is largely because I'm going to reuse these things more than once, maybe. Not positive on that. But it's definitely clean, right? Doing this here means that I'm going to clean up an if statement header. Otherwise, we're doing this like in an if statement header, as opposed to asking if player 1 is greater than player 2. Okay. Again, I like to remind you that once I reach this point, I already know the game is over. Either player 1 has won, player 2 has won, or it's a tie. So all I'm checking to see is if 1 is greater than 2, well, that means that player 1 has won the game. So I'm going to return 1. Else if 2 is greater than 1, what that means is that player 2 ultimately has more seeds, so I'm going to return a 2. Otherwise, and here in this case, you could use the else, right? You could say else return 0, right? This was a tie. What I'd like you to kind of recognize, though, is because we're returning values, I don't necessarily need this else. If this is true, we're going to piece out of the method. If this is true, we're going to piece out of the method. If I'm still here, then we're going to return a 0 because the only other outcome possible is a tie. But I'd like you to notice the way this is organized. I have the most likely scenario all the way down to the least likely scenario. All right, that's the last thing I check. This is going to help with efficiency. Efficiency is achieved just by being a little bit more logical. Okay, why don't we set up some scenarios? We've tested get seeds. I still need to test maybe game over and get winner. So why don't we set up some scenarios for that, right? What do I mean? Let's give somebody no seeds. Okay, simply put, this should trigger a game over scenario, right? Because player 2 doesn't have any seeds. I'm going to try that out. We'll comment out some of this stuff. I'm going to simply ask, is the game over? Answer is true, right? Player 2 didn't have anything. If I give player 2 even just 1 seed, is the game over? Not quite, because player 2 still could potentially make a move. Okay, so the other thing I want to determine is who is the winner, right? Note that if I do game over dot get winner, What should I get here? It should be a -1. The reason being is the game's not even actually over, right? We just determined false. The game is not over, and you see I get a -1 indicating that. What it means is that we can like safely call get winner even if the game is not over. That's not really necessary. It's more of a safety net, right? The other approach is that I precondition get winner so that it only gets called if the game is over. Now, what I need to do is test situations where the game is in fact over to see who the winner is. Here is a scenario where player 1 should be the winner. Okay, so I want to know, we see that we have a 1 there. One thing I need to kind of make sure though is, are we including the Mancala here? Right, because we could just be using get seeds. Okay, so the Mancala is super important. Here's what we're going to do. I'm going to maybe set up some scenario. Let's give player 1 a bunch of 3s, right? And player 2 a whole bunch of nothing right now. Okay, the game is over in this case, sure. All right, in total, player 1 has what? 6, 9, 12, 15, 18, 21 total seeds, right? That should be their score. Let's give player 2 22 seeds in their Mancala, right? I'm just setting up test scenarios. What I want to know is, are we correctly getting the seeds along with the Mancala? And so I'm setting up a situation where the game is over because player 2 can't make a move, but player 2 is actually the winner, right? Because they have 22 seeds total. This includes their Mancala. Right? Player 2 is the winner. What if player 2 only had 20 seeds? In this case, the game is over because player 2 does not have any seeds, but player 1 is the actual winner because they have 21 total seeds. Now, it's easy to test the alternative, right? Which is, what about those situations for player 1? Well, I'm just going to move this stuff to the beginning. This is a situation where the game is over because player 1 can't make any moves. The total seeds for player 1 is just a simple 20. The total seeds for player 2 should be 21. Okay, so the game is over because player 1 can't move, but the actual winner should be player 2. That looks good. And then lastly, we'll make player 1 the winner. And we see that there. Okay, that's where we're going to kind of pause today. And we will pick up in the next video with the move method. I'll see you then.